In this video, we are going to introduce you to two variable equations and graphing. These are the notes, VL-1224. Let's begin. So we've got a one variable equation and two variable equations. Here's an example of a one variable equation. X plus 2 equals 5. And in a two variable equation, we have y equals x plus 2, and y and x are our variables. Over here, we just have x as our variable. So what's our solution? Let's look at the left side. What's our solution for x? Well, what plus 2 equals 5? I mean, we can solve it. X plus 2 equals 5, and we can solve by, subtracting 2 from both sides and finding out that x equals 3. Or, I mean, it's kind of obvious, right? 3 plus 2 equals 5. So how many? So we have one solution. It's x equals 3. Let's look at the right side. What are the solutions for x and y? Now, it's interesting that they said solutions for x and y. Like, what numbers can you put in for these two that would make this equation true? So there's no other number I could have put in to this equation. Like, if I put in 4, does 4 plus 2 equal 5? No. 5 plus 2? No, that's 7, so that doesn't equal. Like, how about, even if I tried to put negative numbers in there, like negative 3 plus 2, that does not equal 5. So the only number that would that we could put in for x would be 3. Over here, y equals something else. Well, let's read further. It says, mathematicians like to say the value of y depends on what value you choose for x. You can write some of the solutions in the table below. So we should choose a value for x and figure out what y would equal. So let's say x was 0. What would y be? So 0 plus 2 would equal, oh, if x was 0, then y would be 2, right? Because 2 equals 0 plus 2. Those would be the same. So I would write my solutions right here. If x is 0, y would be 2. Let's try another set of numbers. Let's say x was 1. So I'm going to choose a number for x. So that's 1 plus 2, right? 1 plus 2 is equal to, what would y be? Y would be 3, right? So y would be 3 because 3 is equal to 1 plus 2. So if x is 1, y would be 3. Let's try another set number. Let's say x was 2. What would y be? Well, that's 2 plus 2. That means y would be equal to 2 plus 2. What would y be? Y would be 4. And you may start to see a pattern right here. What if x is 3? 3 plus 2? Well, that must mean that y is 5. So x is 4. Guess what y would be? That's right, y would be 6. And x is 5. Y would be 7. As you can see, we have this pattern. This goes up by 1, and this starts at 2 and goes up by 1 as well. So let's look at the left side. In one variable equations, x is an unknown number. How many different solutions or answers are there for x? There is only one solution, because there's no other answer we could put in for x. No number we could put in for x that would make this statement true. In a two variable equations, x and y are unknown numbers. They can be the same number or different. How many different solutions or answers are there for x and y? Well, as you can see, I have lots of answers here. When x is 0, y is 2. When x is 1, y is 3. When x is 2, y is 4. And if x is 10, guess what y is? 10 plus 2, well, that would mean y is 12. So how many different solutions can I have for this equation? An infinite number. An infinite number of solutions for x and y. Because whatever I choose, and because, if I choose a number for x, I'm going to get a solution for y. So let's look at another set of equations. So let's focus on this one right here. 6 plus 6 equals 2x. 2 times what equals 6? Well, I'm not going to do the solving. It's just kind of obvious. In this case, x is 3, right? Because 2 times 3 equals 6, right? So let's take a look at this one. What are the solutions for x and y? Well, if x is 0, it'd be 2 times 0, right? And what's 2 times 0? It's 0. So when x is 0, y is also going to be 0. Let's try another one. When x is 1, that's 2 times 1. What's 2 times 1? That's 2. So 2 equals 2 times 1. So when x is 1, y is 2. Let's try a number first. 2. Well, I'm actually going to put a set of numbers 3, 4, and 5. Might as well, because I get to pick whatever I want for x, and then what y is going to equal depends on what I pick for x. So if x is 2, I would have 2 times 2. What's 2 times 2? It is 4. When x is 3, I have 2 times 3. And what's 2 times 3? It is 6. And you could probably figure out the pattern. When x is 4, y is 8. When x is 5, y is 10. Sorry, that's not a very good looking 10. 10, there we go. Can you graph the solution on a number line? Okay, so now we are graphing the solutions. Can I graph x equals 3 on the number line? Yes, I can. It's a dot on the 3. Sometimes you may see the dot like above the 3, just because it can stand out more, but I'm going to go ahead and put this on the 3. Can you graph these solutions on a number line? Well, if x is 0, y is 0, I guess you might think that there's a dot here. When x is 1, y is 2. Like, what does this look like in a number line? Well, the answer is no. Oh, I forgot to write. Yes, you can graph the first one on a number line, and on the second one, you can't. You can't. So let's go to the next page, and we'll figure out why. When we have two variables, our solutions can be graphed on a coordinate plane, which makes sense because a coordinate plane has an x number and a y number. Just like our solutions have an x number and a y number. When we have one variable, we only have one variable answer. Like, we only have an x number. But when we have a two-variable equation like this, we have an x number and a y number, which means we would need a two axes, an x-axis and a y-axis, in order to graph. So let's try to graph solutions to these two-variable equations. You can start by picking a value for x, then solving for the value of y. So we're going to pick values for x, and we're going to solve for y. So I'm going to choose easy numbers. Let's see what happens when x is 0, then 1, then 2, then 3, then 4. And you'll notice this table goes downward. It's a vertical table. And this table over here is vertical, horizontal. It doesn't matter. The tables both work the same. So it's just some people prefer vertical tables and some people prefer horizontal tables. So what happens when x is 0? So 2 times 0, what does that equal? Well, that equals 0, right? When x is 1, what happens? Y equals 2 times 1. Oh, 2 times 1 is just 2, so y would equal 2. See what happens when x is 3. Y equals 2, and replace x with 2. 2 times 2 is 4, so y would equal 4. And you could probably see the pattern. When x is 3, y would be 2 times 3, which is 6. When x is 4, y would be 2 times 4, which is 8. Now, can we graph these solutions on a coordinate plane? And how do we do it? Well, remember, let's look at this right here. Remember, you have an x value and a y value in a coordinate plane. Imagine this being an ordered pair, like this. These are all just ordered pairs, right? There's an x number, and there's a y number. So where is 0.00? It's right there. 0.12, you go 1 to the right and 2 up. 0.24, 2 on the x-axis, 4 on the y-axis. 0.36, you go 3, then 6, then 0.48, 4, then 8. And actually, can you figure out what 5 would be? Or what would happen if x is 5? Well, it'd be 10, so you can actually have a dot right there. And some, actually a good idea, you can actually draw a line connecting those because it's going to make a straight line. Let's try this one. Let's choose, again, let's choose numbers for x. I'm going to choose the easy ones, 0, 1, 2, 3, and 4. So when x is 1, or sorry, x is 0, what's 0 plus 2? Well, it's just 2. When x is 1, what's 1 plus 2? It's 3. When x is 2, y is 2 plus 2, which is 4. When x is 3, y is 3 plus 2, which is 5. And when x is 4, y would just be 4 plus 2, which is 6. So let's try graphing that. 0 and 2. 0 on the x, 2 on the y. That's right over here. 1 and 3. 1 on the x, 3 on the y. Looks like this. 2 and 4 is right here. 3 and 5 right over here. 4 and 6 over here. And guess what? The pattern is actually going to keep going. It would be 5 and 7. If you just chose those numbers, you would see it would make a straight line that looks like that. Let's do one more. And you may say, oh, let me just choose 0, 1, 2, 3, and 4. But these may not actually be the best numbers to use. It's okay. It's actually always a good idea to look at your equation and see if those are the best numbers. But let's go ahead and try those numbers because that's the numbers I chose. So when x is 0, we have y equals 0 divided by 2. And 0 divided by 2 is not 2. 0 divided by 2 is 0. When x is 1, you have 1 over 2. 1 half, and that's what I mean. It's like 1 half isn't the greatest answer. You could have avoided that if, let's see, when x is 2, what's y equal? That's 2 over 2, and 2 over 2 is just 2 divided by 2, which is 1. When x is 3, you have 3 divided by 2, and 3 divided by 2 is 1.5, or 1.5. Again, not the greatest, but that's fine. And if x is 4, y is 4 over 2, or 4 divided by 2, which is 2. Actually, might have been best if I just chose like 2, 4, 6, 8, and 10 for my y numbers, for my x numbers, like if I pick those, but that's okay. It still works out okay. So 0 and 0 is right over here. 1 and 1 half. So 1 for the x, 1 half is like, it's not quite right there, so it's halfway. So it'd be right there. 2 and 1, that's 2 over here, 1 up there. 3 and 1.5, that's 3 on the x, 1 and 1 half. So not quite at 2, but 1.5 right there. And then 4 and 2 would be right over here. And again, you may see a pattern, which is like, oh, it goes up by a half for the y each time. And if you wanted to, you can draw a line going straight through all of these. So yeah, this is our introduction to two variable equations. As you can see, they're very different. Our one variable equations have one solution, and if you graphed it on a number line, it could just be a one-dimensional number line like this, and it's a simple dot. But if we have a two variable equation like this, you're going to have lots of solutions. And how do you figure out the solutions? Well, you pick a number for x, and what your what your y solution is, depends on what solution or what number you put for x. So basically, there's an infinite number of answers. And you cannot graph it on a regular number line. You need a coordinate plane because it has an x and a y number. You need an x and a y axis in order to graph this. All right, go ahead and try some problems on your own. Good luck.